So, good afternoon. Now the next talk after the lunch. I don't know if this is a good thing, but I hope you are still awake. And welcome to this topic of the future of cloud programming, wiring a microservice application architecture to respond to events, which is probably the longest title I could come up with. So maybe I get a prize for the longest title. That would be very cool. But essentially, it's only a talk about a very new technology that is called OpenWhisk, and which is one of the new key players in this very trending field of serverless computing. So maybe one question right away. Who has ever heard of serverless computing? Okay, at least a couple of guys, that's good. Has anyone heard about Bluemix and OpenWhisk already? At least 1-2 people, okay, that's good. So this is what I will talk about today. My name is Andreas, and I'm working for IBM. I'm the technical product manager for this new technology. And first of all, I would like to show you what you will learn today, hopefully learn today. So at the very beginning, I will try to give you a very crisp, to-the-point definition what serverless computing and what OpenWhisk actually is. And then we will meet Dave. So this time we don't want to talk about Alice and Bob because they have already been busy. But Dave has the same problems that Alice and Bob, so that's fine. And we'll show or have a look at how OpenWhisk can help Dave to solve his typical IT problems that we have. And after that little story of this fictive user Dave, we will then dive a little bit deeper into the technology itself. So I will try to explain you how OpenWhisk works, what the value proposition is, how it compares to the competition, how it compares to traditional compute models in cloud computing, what it makes so unique, and then we will have a look at some typical usage scenarios, and then we will have a look at the programming model, and we will do some live coding because I personally think slides are boring. And at the end, of course, we have some time for your questions. So, in one sentence, crisp to the point, what is this? OpenWhisk, in a nutshell, is a serverless event action platform that allows you to execute code in response to an event. So there's some event coming in, some trigger from somewhere, maybe from a service, maybe there's an API call, and that causes code to be executed in the cloud. So the question is, why the heck is this cool? So OpenWhisk provides you with a serverless deployment and operations model that hides any kind of infrastructural and operational complexity, which means it allows you as developer to do what you are really interested in, and that's usually coding. So a slogan could be, give us our code and we run it for you on our cloud platform. The second thing is that we provide you with a fair pricing model at any scale. That means that at any point in time, we provide you with exactly the resources, and not more and not less, that you need to make your program running, and we only charge you for code that is being executed. The third thing is that we provide you with a very flexible programming model because we do not restrict you to any programming language or stuff like that. If you code with our stuff, we allow you to code in multiple languages. So you can code in Node.js, you can code in Swift, and I'm talking here about Swift on the server side. I will come to that later. And you can even execute Docker containers to run custom logic in response to an event. And that actually means you can execute anything that you can package in a Docker container, which is extremely cool. As I've already mentioned at the beginning, there is a commercial offering running on top of Bluemix. For those that don't know Bluemix, we'll I have one slide later where I will introduce that a little bit. But there's also an open source alternative to that. And that is very cool because, especially if you compare to the competition, we avoid any kind of vendor lock-in. So if you go with our solution, you can later on decide, okay, let's deploy that on our stack. Let's deploy that on AWS. Let's deploy that on Azure. We don't care. It theoretically works. But of course, we would prefer that you deploy on Bluemix. But nevertheless, that's available. So let's talk a little bit about Dave, and let's learn about Dave's problems. Let's see how he has done things in the past and how OpenWhisk can help him in solving his problems. So Dave is the lead architect of an online photo community and marketplace. So they operate a platform where people can upload photos and can do some very basic editing, like rotating these photos, sharpening these photos, typically photo editing stuff, and they can manually categorize these little photos by semantically tagging them. So they really have to do this manually, which is, of course, a tedious task, but they have to do that because if they want to sell photos, the other people should be able to find them, right? So they need to categorize them. Unfortunately, Dave's company is meanwhile acting in a very competitive field. So a lot of companies are entering the market and all try to provide the coolest features, the best user experience, all that stuff. So to remain competitive, Dave and his team have to continuously drive innovation. So they have been sitting together, done some brainstorming, and they came up with a simple but very neat idea. So what they realized is more and more of their customers are not using traditional cameras anymore. They really use their smartphones to directly make photos and upload them to a scalable cloud platform. Or they at least use a tablet to organize the photos that they have done in the past via their traditional platform camera. So of course, these people would benefit, these users would benefit from a mobile application that allows them to do that directly. And of course, features like, and I like these pictures here, like sharpening and noise reduction and semantically tagging, most important, would be very, very much appreciated. And when I here talk about semantically tagging, I mean that we automatically provide a function that we analyze the photo automatically and then semantically tag it, relieving the users from the need of doing this manually as they had to do it before in the old world. So this is what they want to do, a mobile application working on a tablet, working on a mobile, with all these value-adding features. And then Dave and his team start collecting requirements, and they start thinking about how have we done that in the past, and what was bad, and how can we do better. So in the past, they have lost a lot of development time by dealing about complex infrastructure and operational stuff. And this time, they want to do better. They want to quickly being able to develop value-adding code. They do not want to care about scalability, high availability, infrastructure security, and all that bullshit. And yeah, Whisk hides this complexity and allows them to quickly develop scalable solutions without the need to worry about these low-level details. And that, of course, radically simplifies the entire development process. That sounds good? Recently, Dave's organization has also shifted towards, and we all have, of course, a highly agile organization. So they have split their organization into small teams, and these small teams are able to quickly deliver small and flexible microservices. And of course, this requires that they also have a flexible programming model where they can reuse the existing skills that these little teams have already developed, and where they can tackle the problem each single team has to solve using the best technology. And OpenWhisk allows them to do that because, as I've already mentioned, they can pick between different languages, which allows the single teams to pick the language they already know, they already love, and that allows them to really develop, depending on the problem that they are going to solve, in a fit-for-purpose fashion. But nevertheless, Dave and his team, of course, they do not want to reinvent the wheel. They do not want to re-implement solutions that already exist just because OpenWhisk is cool and they could do everything on their own. And that is why they also want to have access to a rich service ecosystem of building blocks from different domains like IoT, analytics, cognitive, and so forth, from different vendors. And that is why we also thought in the context of OpenWhisk that making or coming up with an open ecosystem is very crucial. And that's why we encourage people to participate and contribute to even help us building up such an ecosystem of building blocks. So it's not only about that you can develop your actions, your building blocks on your own. We also give you a whole bunch of building blocks that you can use in this context. And all these building blocks come from a huge, huge ecosystem that are playing in totally different domains, the ones I've just mentioned, like IoT, analytics, and so forth. And they come from different vendors to not lock you in with one vendor, which many competitors do. But of course, having these little building blocks is just one thing. At one point in time, you want to stitch them together. So think once again about what Dave wants to do. He wants to develop an application where there has a function for auto-rotating, auto-sharpening, doing noise reduction, doing semantic analysis for the photos being uploaded, and the different teams will take care of these different functions. But at one point in time, we need to stitch together all these little functions. And the cool thing about OpenWhisk is it allows you to wire together these little building blocks in a declarative fashion, which means you do not have to touch the code of the little building blocks. You can stitch them together declaratively, and we'll see that later in the live demo in a little bit more detail. Of course, the little building blocks that have been developed by one team, they can be shared and reused by other teams, so just to prevent that another team has to do the same work another team has already done before. So since Dave and his team are going to develop a mobile application, they're also looking for a solution that makes it easy for them to outsource compute-intensive tasks to a scalable cloud platform. And OpenWhisk makes even that easy for them, because it provides them with SDKs, with mobile SDKs, like for example an iOS SDK, that makes it very easy for them to develop against OpenWhisk. And it also allows them to develop, and I've already mentioned that, in Swift on the server side, which means that a mobile developer does not need to learn a new language because he usually already knows how to code in Swift, so he can just continue coding in Swift on server side, which is pretty cool. In the past, Dave and his team have also been very annoyed about that they have to charge even in times no code was running. So the cost for operating their platform was pretty high. So even in times there was no load at all, where resources were idling around, they just had to pay for this because the VMs were up and running and stuff like that. So this time they want to do better, and they want to go with a solution where they only have to pay when their code is really being executed, which is just one of the value propositions I've mentioned at the very beginning of this talk of OpenWhisk. So at this point, they are actually already convinced OpenWhisk is cool, but I don't trust IBM, that's fine. We want to remain flexible. So in the case that doesn't work out, we want to have the option to deploy that at some point in time somewhere else. And since OpenWhisk is also available as an open source solution, there is no risk for being locked in by a vendor. You can just use this engine at a later point in time, and you can deploy it on an OpenStack, on AWS, on Azure, in theory, that would all work. So you never are locked in. So for those that have not heard about Bluemix before, and this is now about the commercial offering that we have, Bluemix is the cloud platform that IBM has. And if you develop with Bluemix, you have different options to do so. You can go with virtual machines. This is comparable to what you probably know from the Amazon world with EC2. You can develop with IBM containers like Docker. You can develop Cloud Foundry applications. And now the new pillar in this entire world is that you can develop OpenWhisk applications. And one point I want to make here, and this is only where I have the slide in here, is OpenWhisk is not meant to replace the other alternatives that they are existing. They all have their pros and cons. So virtual machines, for example, provide you with maximum flexibility and control. So you can pick the CPU, the memory, blah, blah, blah. But the price, of course, is complexity. You need to deal about all that stuff. If you want to get started easy, you would better go with something like OpenWhisk. But of course, you lose a little bit of this flexibility. So it always depends what you want to do, what the best solution is if you go with Bluemix. Nevertheless, let's have a deeper look. So now that we have learned what Dave wants to do and how it fits into the commercial offering as well as in the open source offering, how it does really work. So the events that cause code to be executed, and that is the code that you have written, your application logic, these events usually come from what we call event providers. And event providers might be services that run on Bluemix, or it might be services that run outside of Bluemix. If there is a service out there, whatever it is, MongoDB or whatever, that has not yet been enabled for us, so it's not yet emitting OpenWhisk events, you can do that for us because we give you the tooling to enable any service. And remember what I just said before, this is what we want you to do. So I'm not sure if you know about this deal, but everyone listening today has the task to enable at least one service for us. Because this rich ecosystem is very, very important for us. I mean, it's cool to have an engine that can react on events, but if there are no event emitters, that might be a little problem. So please do that. So let's have a little bit closer look. So Cloudend, for example, could be an event emitter. Cloudend is a database for those that know that, and they could emit an event, and this event would then arrive at the OpenWhisk engine. And in the OpenWhisk engine, we have rules that have been defined by the developer. And these rules define if this event is coming in, please execute this action, which is your code, and that has been developed in any of the languages that we support. So this is how it in theory works, very high level. There's also an alternative approach to execute one of these microservices, and the actions are nothing else than microservices, by the way. You can also do and follow a more direct invocation. So think of something very simple. You might want to have a web application or a mobile application, and they can do a simple REST call. And this REST call would then also end up at the OpenWhisk engine, and we would once again check, okay, what is the right action to be executed, and just execute it. So for example, this web application or mobile application here might have the task to display some customer data. And the action then that would be invoked would then make a connection to the database, and then we would fetch the right customer data, and we would return it back to the web or the mobile application. So these are the two patterns we developed to execute the actions. So either there is an event from a service, or there is a direct API call that causes this action to be executed. One question that is remaining is, why the heck can this be better than a traditional model? And maybe I should explain that. So let's stick once again to this Cloudend example, which is this database. And you want to execute code just because something has happened in your database. So maybe some data has been added, deleted, updated, whatever. So how would you do it in a traditional model where you do not have a real event programming model? You would usually have a little request, and the request would go to an application. The application would accept the request, and then the application would contain some code to establish a connection to the database, and the application would then say, okay, has there been some change? Fine. And then 5 minutes later, we would ask again. So we come into a polling. Every 5 minutes, something like that, we ask, has there been a change? Has there been a change? Has there been a change? Sounds very efficient to do it that way. There are two problems, obviously. The first problem is related to utilization. So this application that is running on top of a VM or part of a container or has been implemented as a Cloud Foundry application, it's for a long time always waiting for the next poll, for the next request to come in. And that, of course, means that you still pay money, even though this thing is nothing doing, because the VM that is underlying is still up and running. So you have to pay. The second problem here is related to scalability, because at some point in time, you have picked a certain VM. So you have picked, I want to have this VM, and this VM has this CPU, it has this memory, it has this storage. If this is not sufficient anymore, you have to take care about upscaling. So you have to press a button or to set up complex auto-scaling rules. This does not happen by magic. This is something you would have to deal with. With OpenWhisk, the model is totally different. So we have this little trigger, and I've already explained that. The trigger can be the event that comes from a service, for example, the Bluemix service, or it can be the direct API call that comes from a web or mobile application. And then this little trigger arrives at the OpenWhisk engine. And the OpenWhisk engine then checks which rules do we have. what should I do based on this event? And the rules define if this event is coming in, please execute this particular action. And now the magic begins, and of course I'm not allowed to talk about all the details now, but what we do is we deploy these little actions within milliseconds, very, very quickly. This is the tricky part of what we do. And then we run the action, and now we free up the resources again. And that means never ever there is anything idling around. And that means for the very first time in cloud computing, there's a utilization of 100%. So either there's something running, then just because it's needed, or there's nothing running because it's not needed. It's not a 99% utilization, it's a 100% utilization. And this is exactly the reason why we can charge you for code only running. I hope you get that. That is really a very, very cool part. And with respect to scalability, that is the second cool part, is we can highly parallelize the deployment of these actions. So if more load is coming in, we deploy more of these little actions, and we still do this in milliseconds, so we can really ensure that you always have the resources that you need. If less load is coming in, we reduce the number of actions that are being deployed. This is why it is so much better than what we had in the world before. Let's skip this one. So coming to something more exciting, this was the theory. How does the programming model actually look like? So there are three main concepts that you have to understand. The first one is the services, they emit the events as what we call triggers. The developers implement the application logic that is supposed to be executed in response to these events in what we call an action. And the rules associate the trigger with such an action. That's actually all you need to understand at this point. So a trigger is nothing else than a class of events that can happen. So for example, and that's what we have already seen, an event can be emitted because something has changed in a database. So just to make that sure, OpenWhisk is not for solving very particular, very specific problems. It's a general purpose technology where you can execute code in totally different scenarios. It can also be that you are working in an IoT scenario and you want to execute code just because a sensor has emitted an event. So maybe some temperature has exceeded, something like that. Or maybe you are using an analytics service and the analytics service has detected a trend. So maybe you are in the stock trading business and maybe that's the reason why you want to execute code. Or maybe you have just changed your location. So maybe you moved from place A to place B. And that's the event that is then causing code to be executed. Or maybe you use a very ordinary service like Git, and maybe something has changed in your Git repository. No problem, that could be an event, and that event could then cause an action to be executed. The actions are, and that's what I've already mentioned, that is what you as the developer really write, nothing more. They are like event handlers. They react on the event when it comes in. And what I mentioned at the beginning, you have a huge flexibility in how you can develop these actions. You can do this in JavaScript, or you can do this in Swift. And once again, I'm not talking about coding Swift for mobile applications. I'm talking about coding Swift on the server side. And this is a killer feature in mobile scenarios where a mobile developer wants to outsource compute-intensive things away from the mobile device to a scalable cloud platform. He can do that in Swift, so there is no need for learning a new language, for learning something new, which is very neat. And if this is still not enough, because you want to execute in response to the event that is coming from wherever, you can do something. Yeah, you can just execute a Docker container and package into your Docker container whatever you want. So that's a powerful feature, of course. There are a couple of more concepts. I do not want to dive in the interest of time in all of these concepts, but maybe one that is very important. You can also chain these little actions. So what you can do is you can define an action AA, which is the concatenation of three actions that you've written before. You can define action AB, which is the concatenation of the same actions but in a different order. So this makes it very easy to add additional actions, to remove actions, to change the order of actions. It fosters reuse and makes things very flexible. And the point here is this is really doable by following a declarative model. You do not have to change the code of the little actions itself. It's not about hard coding. Hey, A1, please invoke A2. You just have these little microservices and you stitch them together using the tooling that we provide you with. And at the very end, we have the rules. And the rules tell the system which action to execute in response to which trigger. To make your life easier, we provide you with what we call packages. And packages are actually a shared collection of triggers and actions for different systems. So for example, if you want to react on IBM Cloudant, which is a database, or if you want to work with IBM Watson, there are packages that you can just use so that you can react if things are going on in these systems or if you want to write into these systems. And once again, these packages are exactly what you guys can write because we give you the tooling for doing so to make that entire ecosystem even more powerful. So that was boring enough. Let's do some live coding. And let me show how you can really implement these things. So I will now show you how you can implement actions, triggers, and rules, and how you can put together all these legal things. And we start with something very simple. We start with a hello world action that is implemented in JavaScript. Of course, I could have picked a different language as well. And we copy this little code snippet here. We save this code snippet as hello.js. And what we now do is we create the action. And creating the action means nothing else than uploading it to the OpenWhisk engine. So what we use here, we use our CLI, and we say whisk action create hello.js, which means please register an action with the identifier hello and associate it with the content in the hello.js file, which is just our hello world function. So this is very trivial, and we get as feedback, yep, that happened. If we don't trust the system, we can ask the system for whisk action list to see if it has really been successfully created. And I only do this here so that you get a feeling for our CLI. And what we see is the hello action is really there. So what we now can do is we can really invoke the little action. And of course, this here is not about that the action is being invoked because a trigger has fired. This is more for testing purposes. So now we invoke the action manually, and we make this synchronously. That's why we use this little blocking parameter. But we invoke it just to test if we get the result that we expect. So let's invoke it. And let's say whisk action invoke blocking hello. And what we see is that the result is not very surprising because it's, yeah, is hello world. What you also have seen, there was an activation ID. The activation ID helps you to get results back at a later point in time. So you can always ask for the result of an activation that you have done in the past. And if you have forgotten about the activation ID, you can say whisk activation list, and you get all the activations that you have done in the past, and they are sorted, so the last activation is at the very top. And what we can do now, we say, okay, show me the last activations, and of course the topmost should fit the one activation that we just did before, and indeed that's the case. So what we now do is, let's try to get a result again just by using this activation ID. So we do a whisk activation get, and then we just use the ID of this activation ID that we have just seen. So let's do that. And hopefully, once again, we get hello world as a result, and indeed we get this result. So let's clean up the system again, and let's say whisk action delete hello, just to get rid of this trivial hello function. And then let's do a check if there are really no artifacts anymore by doing a whisk list. So first deleting this action. Okay, has been deleted. And now, because we don't trust the system, we do a whisk list. And then we will see there are no actions, no triggers, no rules, nothing available anymore. Of course, so let's just wait for that. And then we see that this has really worked out. And now, of course, working with functions that are not that do not accept parameters is a little bit boring. So let's do something a little bit more complicated, and let's work with a function that accepts parameters. And in this case, it's just a function that accepts two parameters. The one parameter is named name. The second one is named place. So we save it again, and then we register this action again. And it's the same command that we will use now. So we will do whisk action create hello hello.js. That's what you have already learned. And we can do this again because before we have deleted the hello action that we have created in the first step. So let's do that, and we get a feedback once again. OK, it has been created. And now we invoke this action. But now we hand over the two parameters name and place with the values Andreas and Las Vegas, Nevada. So let's just do that. And the result that we get back is exactly the result that we would have expected. So it's just hello Andreas from Las Vegas, Nevada. This time I added the -- result parameter to not get the entire response, but only the result. You can also create actions that use default parameters. So if you do not hand over a specific parameter, the default is being applied. Let me show you this. So I create a second variant of this action, and I associate it with a default parameter that is the place parameter, which is initialized with Las Vegas, Nevada. And then I invoke this variant of the action, but this time I only hand over the name parameter. And if I do this, I nevertheless get back hello Andreas from Las Vegas, Nevada, because the default is being applied. Okay, still no rocket science. The result just as we have expected. So now let's do chaining. This was just how you work with actions. And by the way, I used the CLI here, but of course we also have a visual editor to do this. But this here is more easy to understand. That's at least what I thought. So the next thing I want to do is I want to do chaining. I want to concatenate actions that are then being executed in a sequence. And what you have just seen is I asked the system about these packages that I've mentioned before. So I asked, what are actually the packages that are available here? And I've seen there is a package called util. And now let's see what stuff is available in this util package. And in this util package, I see there are some actions. And one action is called cat, and one is called sort. So for the Linux guys among you, that's very obvious what they will do. The one allows us to sort the array, and the one allows us to concatenate the array. And now I create an action that is the concatenation of cat and sort. It's still not rocket science. It's all the basics that I'm showing you here. We will do something more fancy after that. And now I use it. So let's first create this little action that is the sequence of cat and sort. And now what we do is we use a little text file that is obviously comprised of 3 strings. We copy it in a text file. We save the text file under myhaiku.txt. And then we take the input of this text file and apply it to this action. And hopefully we get back this content of this text file in a sorted order because we do a cat. So we get back the 3 strings, we sort it, and we return the result, right? So very trivial, actually. So let's try if this really works. And indeed it does. So it's sorted. So this was all about actions and chaining. So let's work a little bit with triggers and afterwards with rules. And then we have understood all the basics. And then let's do something reasonable. So let's create a trigger. And it works the same way than actions. So it's a very similar concept. So we say whisk trigger create location update, which could be a trigger that fires if I move from Las Vegas to San Francisco, for example. So we create this little trigger. We get back the information, yep, the trigger has been created. Of course, once again, we don't trust the system, so we ask the system, show me the triggers that exist, and yes, the location update trigger is here. And what we do now, we manually fire the trigger, which is pretty similar to invoking the action manually. So let's fire it. So the funny thing here is, if we fire this trigger, nothing happens. And for those that have really listened to what I've been explaining so far, they will understand why, because there is no rule. So there is no association between the trigger and the action. So what we need is a rule. Let's create a rule that is called myRule, that associates the location update trigger with this hello action that we have created before. So let's just do that. The rule has been created. Let's activate the rule. And then we fire this trigger once again. And now, of course, this should cause that this rule applies and that the hello action is being executed. So now we fire it again. We again hand over some parameters, this time Andreas via trigger and the place Las Vegas. And what we now do is we ask for the activations. And we see that the topmost activation is the activation of the hello action that is expected. And let's see what the result is. And hopefully the result this time is Andreas via trigger from Las Vegas, because this is what happened because this rule has applied. So now you have learned, yeah, and here's the result that we have expected. So now you have learned how the basics work, how you can create the action and how you can create triggers and rules. Let's do something more reasonable. And the next thing I would like to do is, based on a change that happens in GitHub, in a GitHub repository, I want to post something to Slack. This is a little bit more exciting. And so let's just do that. And first of all, we check what packages are available. Maybe there's once again something that we can just use. And what we see is there's a package called Slack and a package called GitHub, very surprising. And of course, we want to make use of these. So the first thing that we do is we bind to the Slack package because we want to use it. Binding is like create a copy and hand over your credentials so that it is associated with your Slack account. That's very easy. So let's create a binding to the Slack package. And now let's look what actions are available in that Slack package. And once again, we say whisk package get summary whisk system Slack. And what we will see is there's one action in there that is called post. And if I call this post action, I can post to Slack. That's what it says. So let's once again ask, invoke the action manually and say my Slack post and hand over some text. And then I quickly open my Slack account. And hopefully something is happening. But this is still boring, because this has not happened because I changed something in the Git repository. This just happened because I invoked it. So let's now create a trigger for GitHub and combine these two things. So once again, let's check what we have in the GitHub package. And what we see is there's a feed. So there is something, there's a webhook. So you do not need to understand the details here. There's a webhook, and the webhook fires if something is changing in a GitHub repository. So once again, we bind to this GitHub package. So we give over our credentials. That's what we do here so that we can work with our GitHub repository. And now we create a trigger. And this trigger fires if the webhook is being invoked. The webhook that is being invoked because something has changed. So let's create a little trigger. And then we create an action. And the action is being invoked if this trigger fires. And all this little action does is it calls the post action on Slack. So then if I go to the GitHub repository and do a change there, the trigger fires, the action is being called, and then finally something is being pushed to Slack. So I've just created a trigger. Now I create the action. And then I create a rule to associate both to each other. Let's create a rule to associate it. And now I go to my personal Git repository. Very quickly. Yeah, I have to enable it. I make a change in the Git repository, and then I should see a change on Slack. So let's quickly open Slack to see if it really works. And it really does. So I need 2 more minutes, I hope that's fine, for the final demo. So let's once again think back of what Dave actually wanted to do. Dave wanted to implement this mobile application, where he first wants to auto-sharpen the photos, then he wanted to semantically analyze the photos, and he wanted to do noise reduction. So if you have really listened to what I explained, it's very easy, right? The first thing that he needs is a trigger. The trigger fires if a photo is being uploaded to a cloud and database, because if someone does the upload from his mobile device, the trigger would then fire. And then the different teams would then implement these little actions. There would be one action for doing the semantic analysis of the photo. There would be one action for doing the sharpening. There would be one action for noise reducing. And then we would create a chain, because we want all this happen in a sequence. So we would create a chain that is called my chained action, comprised of all these little actions that all these little teams have developed as little microservices. And then we would create a rule that says, if this trigger fires, which fires because the photo has been uploaded, please execute this chain, and that's it. So the teams can develop totally independent and can wire that together. And the code for the full analysis could be written in Node.js, because that team are Node.js experts. And they could make use of the services, part of this cool ecosystem. For example, where services like Watson and Alchemy are in, the sharpening thing could be implemented in Node.js as well. And maybe the thing for doing noise reduction could be a Docker container that has just been downloaded from Docker Hub, because it was already there. So these puzzle pieces are now being put together. And then in the end, Dave has the solution here. Sorry for that. Dave has the solution he ever wanted. So this here is the solution Dave has developed exactly the way I've explained it. So we go to this application, we pick a picture, this time the picture of the Eiffel Tower, and once I've selected it, it's processed. It's noise reduced, it's resharpened, all that stuff. And what you also see, it's semantically analyzed using the IBM Watson service that can understand pictures. And what you see here, the service has detected, this is the Eiffel Tower, and it's a landmark, and for some reason it's blue. That's probably because of the heaven. Sorry for that. But this is exactly how we can build, and this is the proof how OpenWhisk can really help Dave to quickly develop such a kind of solution. Sorry for having taken 3 more longer than I had. Thanks a lot for listening. Thanks a lot for your patience. Thanks for having me here. If you have questions, I will be around for 20 more minutes and I have to fly back to Germany. Thanks a lot.